Alright guys, this next chapter is all about non-linear equations. But to start, we're going to do a linear equation. It says graph the following. Now, y is equal to negative x plus 4. I would hope that you would recognize this as y is equal to mx plus b form. And you would know that b is the point 0, 4, so you plot the point 0, 4. And our slope, there's a negative 1 in front of this x here, right? So that means our slope is negative 1, which means our slope would go down from left to right. So down 1, right 1, down 1, right 1. Make a bunch of dots, or if we went up 1, left 1, of course. But our line would look something like that. Hopefully your line's a little bit straighter than mine. I'm not using a straight edge. But back when we first started to graph lines, before we knew y is equal to mx plus b, we did a table. And if we were to take these values and plug these in for x, this says the opposite of x. So if x is negative 2, the opposite of negative 2 is 2. Plus 4 is 6. Y would be 6 then. The opposite of negative 1 would be, or negative 1 times negative 1 is 1, plus 4 is 5. The opposite of 0 is 0, plus 4 is 4. And you might see a pattern here, 6, 5, 4, 3, 2. And if you checked, if we plotted these points, check this out, the point negative 2, 6, that's one of the points that we plotted. Negative 1, 5, that's right there, 0, 4. All those points are indeed on our line here. All right, so the moral of the story is that making a chart is always helpful. If you don't know what a graph looks like, if you make the chart, it'll show you what it looks like. So now we're going to look at some stuff that is considered non-linear. The first couple might seem like lines, but they're actually not lines. Let's see why. This first one, these bars were the absolute value bars. Remember, absolute value means always positive. We should say it's almost always positive, because the only time that it's not positive is 0, right? 0. The absolute value of 0 is 0, which is neither positive nor negative. Anyways, the absolute value of negative 2 is 2. Plug in x in here and you get 2. The absolute value of negative 1 is 1. 0. The absolute value of 1, remember it's always positive, would be 1. The absolute value of 2 is 2. So we don't know what this looks like just by graphing it, so we made this chart. And plot these points. Negative 2, 2. Negative 1, 1. 0, 0. 1, 1. And 2, 2. So you plot those points. Look at this. This kind of makes a V. If you think about it, if we went the absolute value of 3, that would be 3. The absolute value of negative 3 would be positive 3 as well. You can kind of see how this graph would do this. It would make kind of a V shape. It would go up like that. Now, these look like two lines, but because it is two lines going in two different directions, we consider this a non-linear graph. All right, let's do the same thing here. We're going to go with negative 2, negative 1, 0, 1, and 2. Whenever you're given a choice to make a table, oftentimes it's a good idea to go with a couple negatives, 0, and a couple of positives. So here's what's up. The absolute value of negative 2 is 2. Minus 3 is negative 1. Absolute value of 1, or excuse me, negative 1 is 1. Minus 3 is negative 2. Negative 3. Absolute value of 0 minus 3. And then you should get negative 2 and negative 1 by plugging those in. So plot these. Negative 2, negative 1. Negative 1, negative 2. Check your dots with mine. Your dots should look like this. If we draw this, this is the exact same graph, right? It's absolute value just like this one. Except this minus 3, what did this minus 3 make it do? It looked like it dropped down 3 units. Huh. Let's go to the next one. Square roots. Square root. What is the square root of -1? Are you allowed to take the square root of -1? I don't even know. I'll tell you what, if you pull out your calculator, there's a weird graph, huh? Are you allowed to take the square root of -1? Oh man, the calculator gets fussy. You're not even allowed to do that. All right, what's the square root of 0? Remember, if you're not sure what square root is, use your calculator. Square root of 0 is 0. Square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So you plot these points. 0, 0, 1, 1, 4, 2, and 9, 3. That's a strange looking graph, isn't it? Looking like that. So what I would recommend, doing the same points again. -1, 0, 1, 4, and 9. Square root of -1, you can't do it. And can't do it -3 means you still can't do it. Square root of 0 is 0. -3 is -3. Go ahead and fill out the rest of the table and do your graph. Go ahead and press pause and then check with mine. Huh, look at that. Mine came up with this. Again, same shape graph, just went down 3 this time. All right, let's go page 3. Again, x squared. Tell you what, -2 squared. That means -2 times -2. Negative times negative is +4. If you use your calculator to put in -2 squared, make sure you put parentheses around your -2. -2, and then to the second power get squared, or get +4. If you do it like this, -2 squared, you will get the wrong answer of -4. It is positive. Same thing with -1. Parentheses, -1 squared is +1. 0, 1, and 4. So go ahead and plot these points. So is this linear? If I were to draw a line, can I get all 3 of these points in any one line? Not quite. Can't quite get all 3 of them. Just for fun, let's add another point. What is 3 squared? 3 squared is 9, so that would be, whoa, that's way up here. What about up here? What's -3 squared? -3 is also 9. Way up here. So you can see this is definitely not a line. This is a curve. Looking like that. So tell you what, give this last one a try. Press pause. Fill out the table again. Use the same X's and see what you come up with. Go ahead and give it a shot. So I got these values. Do these surprise you at all? Let's look at what happened. When x is -1, this says -1 times -1 squared plus 5. If nothing else, pull out your calculator. And if you put this whole thing in at once, you put negative parentheses, -1 squared plus 5. And you'll see that you get the answer of 4. So, go ahead and plot these points. Let's see if yours agrees with mine. When you plot these points, it might be kind of an unexpected shape. This is like the last shape, except that it opens down. What do you think made it go and open down? Take a guess. Look back at the original equation. What do you think made it go and open down? Let's go on to the last part. Quadratic graphs can be used to describe a number of things. Quadratic is one of these arc things. These parabolas is what this is called. We'll talk more about that as we go. It describes the path of an arc or the path of a basketball after it has been thrown. Now I'm going to start this problem by saying this is a very unrealistic problem. If you look at this, we throw the ball, we throw this ball, and it says time after the ball was released. If you were to slowly go ahead and count to how long does this ball stay up? For 9 seconds. Think if you could count to 9 and think if you could throw a ball high enough that would stay in the air for 9 seconds. Go ahead and press button and give it a shot if you want to. Anyways, so here's what's up. How far off the ground was the ball when it was released? Now, remember, our x-axis is time after the ball was released. So when it was first released, that's at time 0. That's right here. Our y-axis says it's distance off ground. So when the ball was released, the ball was 2 feet off the ground. How high was the ball at its peak height? Well, look at the peak height. Where's the peak? Where's the highest height? The highest height is right here, way at the top. How high did it get? Got up to 10 foot. And how long did it take? Well, it got up to 10 feet. How long did that take? Well, we look at our time. Our time here says it took 4 seconds. When did the ball hit the ground? Now, I kind of alluded to this at the beginning. The ball hits the ground right here. All right, this is kind of the path of the ball. It was 2 feet up, went up, came back down, and hits the ground right here. How long did that take? Well, it didn't take 8 seconds, and it didn't take 9 seconds. It looks like it took about 8.5 seconds. 4 is tricky. When was the ball 8 feet off the ground? Well, here's 8 feet. 8 feet happened right here. And where else did 8 feet happen? It also happened right here. 8 feet happened twice. So it happened at about 2 seconds. And it happened at 6 seconds. So why are these two answers? Why are there 2 answers for the previous question? Why is there 2 answers for when the ball was 8 feet? Well, think about it. The ball went up. The ball went up and passed 8 feet. Ball went up and passed 8 feet. There it is there, right? Then it continued to go up. Continued to go up, but then what happened? It fell back down. It fell back down and passed the 8 foot mark again. All right, so it has 2 reasons because what goes up must come down. All right, so that's a little bit about non-linear graphs. Let me know if you have any questions. Smith out.